So, good morning to one and all. Welcome to the webinar series by SmartBridge. So, this time we are doing a webinar on cloud computing. So, for those who have not known about SmartBridge, we are an edtech company. We've been founded in 2015. So, it's more than 5 years now. We've been mainly into building the next gen talent pool on emerging technologies. Our main goal is and motto has been to bridge the gap between academia and industry. So we've been doing it via so many programs over the years. So right now we have a remote internship program. I think most of you already got mails from AICTE and you might have gone through our program and portal. So I'll talk about the remote internship and the benefits of that free internship program later on at the later stage. But right now, as the clock is ticking, let me introduce you to our key speaker. It's a privilege for us to have you, sir, Mr. Sharad Babu. He is a director product development at Oracle with 22 years of experience and established track record in successful product development, strategy, delivery management, handling cross-functional responsibilities, and has a tons of global experience, including management experience, and can't find any other perfect speaker for today's webinar. With utmost pleasure and applause, I welcome Mr. Sharad Bambu to take over the session. Sir, over to you.
Thank you, Vishnu. Good morning, all of you. First of all, I would like to thank SmartBridge for giving me this opportunity to interact with you all. Today's session, cloud computing, I know you're all excited to know about this. So let me set some expectations on this session. And this is more giving a broader landscape about the cloud computing, and you might have seen a lot of buzz around this topic, and you might have seen a lot of traction and all that. So we'll try to see, starting from the background, and we'll try to get to some real architectural aspects on how things will be implemented and all that. So that's going to be the agenda part. So in terms of the execution of this session, I have one of my colleague, Kiran, who is also part of this seminar. So he'll be helping me on hashing out some of your queries on Q&A. So feel free to type in your questions. So basically what I want to do is I have some 5 session or 5 topics. I segregated this entire session into 5 or 6 items. So at the end of every item, we'll have some pause and we can probably take questions. And also definitely the other option is we can take at the end. And in between, anyhow, Kiran is going to support you on the Q&A. So that's the way we'll try to handle. So without any further ado, let me just open my slide deck. So I'll be having around 30 slides, which I'll be going through now. If you can see this agenda, right? As I mentioned, I segregated this into 5, 6 topics.
One is your screen, sir.
Oh, sorry. Yeah, thanks, Vishnu, for letting me know on that. Though how much ever I've done on this, still now I keep forgetting on this. So thanks for reminding me. So is it visible now, Vishnu?
Yes, sir. It is visible.
Okay.
Voice is audible.
Okay, perfect. So coming to the agenda, so what we'll do is we'll try to quickly look back on the background and the context setting on why we really need the cloud and all that. And we'll jump onto some of the concepts on the cloud computing and getting onto the deployment, typically whatever the containerization, Docker, these things you might be hearing so far. So we'll talk a bit about them. And then we'll get onto the cloud architecture where we exactly would like to get onto how these cloud service providers, right? Be it Azure, be it Amazon, or be it Oracle, all these companies, how they really implement these aspects. So that is something we will touch upon in the architecture part. And in the other cloud features, we'll try to touch some of the other additional aspects, be it high availability, security, how we can really get onto the pricing. So that is about the other cloud features, and cloud opportunities and skill sets is more relevant to you. So at the end, the key takeaways for you will be like, okay, I learned about all these things. So what next? What is that I need to do? Where is that I need to put my energies? So these are some of the questions probably you might be having. So the last part is just to touch on some of the areas where no, I think you can focus and you can probably get benefit out of this journey, right? So that's what is my small agenda. And let's jump onto it without any further delay. So in the context and background, so I think I don't need to probably talk more on this slide, but I just put it to just as a recap of how we evolved to what we are seeing today, right? So as you all know, we started with mainframes and we started getting on to personal computers where we started seeing a lot of distributed computing, and we have seen applications getting developed in client server technologies where at that time the business logic used to be distributed between client and the server. So the thing is, it used to be a lot of maintenance. So if at all, if I need to change something, I think it has to be changed across all the clients. So that was the client server. And typically when I started my career, I was basically a client server developer. So I was working on Visual C++, Visual Basic and all that. So those are the technologies I used as to develop these applications. So, and slowly we got Java, and Java with all its capabilities and robustness and all, as you know, all the platform independence features and all that. Slowly Java, it also started with client server, and slowly it has more known for your web applications and all that. So that is when we have seen all this stuff. So basically what I'm trying to say here is, okay, we have seen all this, but we never stopped, right? The journey is moving on. We are trying to improvise ourselves on a regular basis. So what are the typical challenges we are seeing? So in all these phases. So for example, if you take your internet or web applications, so what exactly is going on is typically you will be working in a request response mode. So the thing is, the end user is submitting a request, and a web server will be there, which will be sending you the response back. So this was okay, but the thing is, these web applications are scalable and the load is more. So what we started looking at was, we don't want the server to choke after some kind of threshold, right? So we started expanding those servers also. We started adding more and more servers and creating more and more, what you call, flexibility to add more users and handle more loads. So this way, we try to avoid the single point of failure. But the thing is, when you have so many servers, you need what? You need some controlling point to handle these servers. So that is when we started thinking about load balancers. So we introduced load balancer, which can take care of to what server I need to route my traffic, right? So that is what is the load balancer thing. And we have seen, we also try to introduce redundancy with load balancer, because if at all, if the load balancer dies, but it still should not stop the work, right? So we introduced redundancy in the load balancers. And we also said, okay, load balancers can be primary, secondary, standby. So whenever one is down, the other can take over. So ultimately the goal was the availability, and we want to avoid the single point of failure. So the thing is, for the end customer, the business has to continue. So that is what we try to ensure. But the challenge what we have introduced with all this complex landscape or complex infrastructure is, we have introduced more servers, we have introduced more load balancers to connect all these networks. We had more routers, we have more switches. So the thing is, things have become more complex, both in the form of hardware as well as in the form of software. So you may be wondering, why is this complex? Means the complexity is because these softwares and hardwares keeps on upgrading, and You may be always seeing a lot of patches coming in, a lot of upgrades happening. So the thing is, it has become a big, really bottleneck for the organizations to keep up with that. So they need to set up one IT team who has to handle these upgrades, these patches. They need to keep a constant vigil on the IT infrastructure. So they are slowly, what you call, looking that as an activity which is not their focus area. For example, if you take a bank, so bank will be more interested to innovate in coming out with new products in the form of deposits or in the form of loans or whatever, right? But most of their energies are getting onto these. They need to employ a lot of these IT people, and they need to put a lot of energies and money on these aspects. So the thing is, their ability to innovate in their core area is getting diverted because of all these complexities. So they were just thinking, what is that which can probably ease this job, right? So that is when this cloud computing has come. So the people said that, okay, don't worry about infrastructure. We will take care of it. You just focus on your business. So we will take care of maintaining your complex setup. We will scale your infrastructure. We will take care of your maintenance. We will take care of your upgrades. We will take care of your patches. So that is the way I think this cloud servicing has, or cloud computing has evolved over a period of time, right? So this is a quick snapshot on my first slide. Coming to, I have two more things to set the context. The another important point I would like to hear is, slowly we also started seeing from a business side, we started seeing the shift from product to service, right? So earlier, no, everybody used to develop and manufacture products, be it software products or be it physical products or be it mobile phones, whatever. But today, everybody is looking at, along with the product, people are also looking at the service part, right? In the sense, like, you can just think service as something like a customer experience, right? For example, if you take iPhone, so the thing is, when you take iPhone is a very good mobile, but more than a physical device, iPhone is meant for what? Meant for its ecosystem. So it also developed a, what you call, operating system. It created a platform where no people can develop apps and people can make this device more and more usable. So it can help businesses, it can help people. So this is what is the customer experience, right? So the shift is just focusing from product to service and the customer experience. That is what is one shift we are seeing. Second thing is transition from stability to agility and innovation. So what I mean by this is, if you look at the history, right, slowly the companies are coming down. Like, companies used to rule for longer duration earlier in the olden days. For example, if you take even companies like Kodak, right, which is more in the photography, you might have seen the camera rolls and all that. It was there for about 100 years until it got disrupted by the digital revolution, right? Similarly, slowly what happened, that 100 years domination has come down. And when we started seeing computers, personal computers and all that, so Microsoft started dominating. So Microsoft also dominated for how long? It probably dominated around 25, 30 years. But then what happened? We have seen from Microsoft to, we have seen Apple, and then we have seen Google, and then we have seen Facebook, and now we are seeing Zoom. So the thing is, all these companies are, their domination has been shrinking as we are moving from one level to next because of whatever the agility and innovation we are seeing. So this is what I think is the shift we are seeing. So Hi, Vishnu, am I audible now? Vishnu?
Yes, Sharath, you are audible.
Okay, thank you. Sorry, guys. There was a power disruption at my place, so I just had a quick break. So sorry about that. So yeah, so that's what I was telling. So the thing is, the agility and innovation has made the field more and more competitive and all that. And the third point is digital infusing physical, right? So today, I think you might have heard about Industry 4.0, where no, we are talking about anything connecting to anything, right? So you are making devices to talk, and that is one part of it. And also you are talking about omni-channel, right? In the sense like you want to carry that experience across. What I mean that is, suppose I have my mobile phone, I have my laptop. For example, I was doing my say I was chatting with one of the websites for a service, and suddenly I have to move. So what I did was I just left my laptop and I picked the thread from my mobile. So when I pick the thread, whatever the conversation I was doing till that point, that will be carried forward and I can start exactly where I left, right? So that is basically the omni-channel experience. So I think so all these are the important drivers what we are seeing today. So you might be wondering how these are linked to the cloud means. So the first thing is outsourcing the infrastructure, and the infrastructure is also matured today to handle all these things is what I'm trying to highlight. Because for people to really get all these things individually takes a lot of effort, a lot of energies. But if at all, if these things can be handled by a cloud service provider, that will be seamless and simple is what I'm trying to highlight. The last important point is the market and industry expectation. So typically, the industry looks at three things. So one is any product or service you develop, it has to be simple and easy to use. So the thing is, today, if you take, for example, India itself, we are talking about what? Around 450 million people who have smartphones. So the thing is, and most of them may not be really knowledgeable on working with these apps and all that. So what makes it any app more appealing is if you can really develop something which can be leveraged or which can be used by any of these 450 million people, right? So that is what is the key point which I want to drive. So simplicity and ease of use is one expectation, and time to market. Time to market is because we are in the fast changing world with so many new requirements, especially right post COVID-19. I think we have seen a lot of people innovating on a lot of areas, right? Be it ventilators, be it sanitizers. People are talking a lot about how we can bring more apps, more portals. So how you can bring these things quickly to the market, right? So that is one part. Second part is the time, total cost of ownership. So be it direct.
Sharath, sorry to interrupt you. Can you please share the screen?
Yeah, sorry again. Thanks again. Okay. Vishnu, I think you probably need to help me. It is saying that I cannot share host disabled participant screen sharing. Hello.
You are audible, Sharath.
Vishnu, somehow I'm not able to share the screen. It is saying that host disabled participant screen sharing. Vishnu, you there? Vishnu, you there?
Please unmute, Sharath.
Okay. Let me see if I can call him. Guys, just give me a sec. I'll parallelly check with him, but let me continue. I'm just slid on the same slide. So basically what I'm trying to tell is, like, we have, the first thing is we understood what is the need for cloud computing. Second, we understood that what are the important drivers which needs for which is required for any of these product or service companies. And the third thing is, what are the key things which the market is looking at or industry is looking at, be it simplicity, be it time to market, and be it on the cost. So these are the three slides which talks about the three dimensions, which is really what do you call showcasing that this is the need for cloud computing, right? So that is where I'm done with my first background and context setting. So just give me a sec. Let me just check with Vishnu on this slide sharing. And meanwhile, you can just put your questions on the slide, and then I think we can take it from there. Yeah. One second. Sorry, guys. I think I'm not able to get hold of the moderator. Somehow, no, my access to sharing the screen got disabled. That's the reason I'm not able to showcase this presentation. But I'm just trying for Vishnu to help us out. But meanwhile, I think we'll continue in the interest of the time and all that. Okay. So any questions so far on the background context setting? No, right? Okay, I think let's jump on to the cloud computing concepts. So you all know that by now, what is exactly the, so whenever people talk about the cloud computing, what comes to your mind? So this was the question I used to ask myself when I started thinking about cloud computing. So what comes to my mind was typically the electricity bill or the utility, right? Be it water or electricity. So like it all is so efficient and so effective that whatever the electricity we consume, we pay for it, right? We don't need to worry about how this all power comes to our houses and what kind of activities goes behind the screens. So we don't need to worry about all those things, but we will just use whatever we want and then we will pay for whatever we use. So during, say, winters, if we use a lot of heaters, probably we may be consuming more. And similarly, when we use more ACs during summer, we may be again consuming more. So it is fluctuating, right? And it is based on the utilization you'll be paying. So similarly, the compute also, like, we thought, like, why can't we leverage the same concept for the computing? So that is when actually all this cloud computing has made sense and all that. So one second, yeah, I think screen sharing is something which is, because without showing, no, probably you may not be able to visualize more. Guys, just be patient. I'm just trying to reach out to uh, the moderator to help us on this. I know it is frustrating for everybody, but this is what is the new norm, right? So we all need to depend a lot on infrastructure. This is really tough to uh, show without the slides. Kiran, can we try anything else to share the screen? Because this is not working. I tried to rejoin, but it is still, and I'm not able to reach Vishnu also. Just to see if he can help me.
You are still a panelist. One second. Let me try out to share the. No, I am also not, I am also a panelist, but don't have privilege to share the screen. Post disabled participant screen sharing. That's the error I am getting.
So I'm just wondering what else I can do, because he's not available and he's not picking my phone. And guys, really, I'm sorry. Apologies. So I'm just trying to trace this guy. Just please be patient with me. Okay, so I think let me talk. I know little difficult to visualize things without showing the screen, but I'll try to do my best to highlight the points. And once we get access to this screen sharing, I can probably run through the slides. So just let's continue the discussion. I know this is little constrained, but let me try my best. Okay. So yeah, so I think we were just talking on the cloud computing concepts, right? So we mentioned that this is more of a utility-based aspect. So and it is like we want to take the compute to that level where we just want to use and we just want to pay for whatever we use. So why people exactly got this thought of, okay, we need to probably think about taking the compute to utility means. If you remember, right, when we started this journey on the IT, everybody used to develop applications based on the platform they have, right? Some applications we used to develop in Linux platform, some applications we used to develop to work on Windows, and
Hey, 1 second. I think you can share the screen now. Sorry for the delay.
oh yeah, thanks, Vishnu. I was actually trying to reach to you, so
Yeah, sorry. Yeah, can you share the screen? Yes.
yeah. So actually, both things. There was a power disruption at my place, and this also suddenly got disconnected. Yeah. So guys, I think you are seeing my screen now, right? All of you guys. Kiran?
Yes, Sharath.
Okay, good. Sorry guys, I know sometimes things happen. So let's continue. So what I was telling is, so when we have these different platforms, applications targeting different platforms, so the organizations used to invest, okay, if at all, if there is an application on Linux or Solaris, they used to buy one Solaris machine. They used to keep that application there. But that application may be running once in a while, say probably once an hour in a day, or probably some applications may be running like once in a week, once in a month. So if you look at that, the utilization of that resource was really limited, right? So the thing is, similarly, they used to invest a lot on this hardware infrastructure, but they used to use them very less. So that way there's a lot of wastage of these efficient resources. So that is when I think there is a concept called virtualization has come into picture. So what the thought was, okay, as we are really missing on using these efficient resources, why can't we probably take the same hardware and I can use it one for probably create a virtual machine, which can probably be used for a Linux application, and create another virtual machine, which can be used for a Windows application. So that is what was the evolution of the virtualization. And from then, actually, once the virtualization has come, so that they started focusing on the infrastructure a little more, because every organization used to have their own data centers. That is what is your traditional data center. But again, the challenge with that is, if you take your typical compute, you will have compute, which is your typical processor, and you will have your networking equipment, you will have your storage, be it disks or whatever, RAID, whatever, right? So all these are three different, what do you call, entities. These are all provided by different service providers. So that way, what used to happen is uh, always they used to have different schedules. There will be compatibility problems. For example, typically all your compute used to come from VMware. You used to get networking equipment from Cisco, most of this disk storage and all that from IBM. So this way, if at all, if these three organizations are not in sync, the people used to really see a lot of problems in the compatibility, downtimes, because sometimes what happens is Cisco may say, hey, I'm doing an upgrade, so I want to bring my equipment down, and they will generate a new patch or new upgrade. So these complexities used to be always there. So that is the way what happened. They started moving from traditional data center to converged infrastructure. Converged infrastructure is nothing but, so though all these compute, storage, and networking were served by three different organizations, one person used to take the ownership of all these three, and they used to say, boss, don't worry, I will take care of clubbing all these things together, and I will provide you a converged infrastructure. And Cisco used to do that. They used to collaborate with all these other vendors. They used to give that converged infrastructure. That is the second level of evolution on the infrastructure. And third level of evolution is your hyper-converged, where we completely virtualized everything such that you will be giving one box or one virtual box which can have all the compute, storage, and whatever, right? The networking together virtualized. So all these things called as software defined machines, right? So that is the evolution we are seeing on how we can make infrastructure more efficient. So we started from siloed infrastructure. We started thinking about virtualization. From virtualization, we started looking at converged infrastructure. And then now we are talking about hyper-converged infrastructure. So these are all the phases which have helped in terms of taking this cloud computing to the next level. So with all this background, let's see the definition of cloud computing now. So this is a typical Wikipedia definition. I think you yourself can go and check it out. So what it is trying to say is like, it is more like you developing your applications which can be enabled and accessible from any device, be it your mobile, be it your laptop, be it your iPad. And this can use the heterogeneous equipment, be it hardware, networking, storage, services, interfaces, and all that. So that is what is. So cloud, the main thing is whatever you want to get it with ease, and your payment should be more limited to whatever you have used. So these are some of the key things which should come to your mind when you really talk about cloud. And this is one more definition from NIST. NIST is National Institute of Standards and Technology. This is an US organization which really does a lot of research and a lot of work on these aspects. So they define cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. This cloud model is composed of 5 essential characteristics, 3 service models, and 4 deployment models. We'll talk about all of them. So I can touch about all these points, what he mentioned, on demand and resource pooling and all that in the next slide. So if you see here, the essential characteristics, these are all again the summarized version of the previous definition. On-demand self-service means, today I can tell my experience. If I want to procure one server in my organization, I need to raise a procurement request that has to be approved. And the organization who has to supply that, they have to ship it, we have to get it, and we have to configure. So by the time we make that equipment work, it will take probably minimum 1 week, or sometimes it may take 2 weeks, 3 weeks, and all that, right? But on-demand self-services with cloud, I think this is like a splash, in the sense like, if you just want to have a virtual server with say 32 GB RAM and say 1 terabyte of hard disk, with a flash, you can get that particular server to you. So this is called on-demand self-service. And the thing is, you don't need to depend on anybody. These things can happen just like that. And earlier, no, you may need to depend on your IT people to help you out to configure and all that. You don't need to do anything. It is like self-driven, and you yourself can do it easily. And all these can be accessible. Broad network access means all these can be accessible on various devices, because all these devices share the common network. Then the next thing is pooling, right? Pooling in the sense, all these resources can be pooled and they can be leveraged. Suppose as an organization, I may have, say, 10 applications working on. So these 10 applications may be having the resources, like be it hard disk, be it compute, be it networking. I can pool and share it, in the sense, whichever application needs more compute, I can probably divert that compute to that particular application. So that way, I don't need to keep a dedicated pool of compute or dedicated pool of storage for either of these individual applications. So that is what is your resource pooling. And rapid elasticity, this is again, you can take it up and down, in the sense, if you want to shrink your usage, you can shrink. If you want to expand, you can expand. So for example, during festival seasons, your websites may be more, attract more traffic, right? So at that time, you may need more compute, you may need more storage. So you can quickly expand your what you call server capacity, storage capacity, and all that. And whenever it is off season, you can bring it down. So your payment will be basically dependent on these parameters, on how much you are going to use. So you don't need to worry about doing an upfront investment on the cloud resources, on the infrastructure, and then keep incurring the cost. So it is basically on demand. It can shrink and expand when needed. It can meet your business demands. So all these are the important characteristics. And the important point at the end is your measured service, right? In this, it is basically the way you have your electricity bill metered and billed, right? Whatever you consume, you are paying. Similarly, here also, at the end of the cycle, you may be paying for whatever the resources you consume. So that is so these are the important essential characteristics which you can think about when we really talk on the cloud computing. So coming down, there are some deployment models. So you may be wondering, what are these public cloud, private cloud, and people also talk about hybrid cloud, and why we need to worry about all these things. Means any organization, so there is a difference. Public cloud is more open, it can be easily scalable, and you have to share this infrastructure with other organizations. So that means some organizations may be very sensitive. They say that, boss, my information is very sensitive. Say for example, a bank don't want to share their infrastructure with some other organization. So they may say, no, boss, public is not my cup of tea. I want my dedicated this one. So this particular compute and dedicated compute power, dedicated storage, I want to use for myself. So that is your private. So what is the difference is, like, the public will be cheaper, because that is like for the cloud service provider, it will be like volumes, right? Because they have so many people, so many organizations, and when you are sharing the resources across so many organizations, the cost will be, the economies of scale will come into picture and cost will come down. But if there is anything dedicated, you will be having a more cost or more premium to be paid on that. So that is the difference between private and public. So typically organizations, what they do is, they will take a cautious approach, in the sense, they start with private, okay? And so first they'll keep all their data centers private, but they still want to gain the efficiencies of virtualization, efficiencies of on-demand provisioning, expansion and shrinking. So keep an eye on the efficient resource utilization. So they want to get the benefits of all that, but they want all the resources to be dedicated to themselves. So that is where they start, and slowly what they will do is, they may slowly leverage the public internet public cloud for some of these very insensitive workloads. Like for example, if I want to do some development, if I want to do some testing, so I may go and say that, boss, I'll do these things on my public cloud because it is all test data. I don't need to worry whether I'm not so worried about the security aspects. So I can still do that. So the thing is, organizations typically start with private mode and slowly they start opening up and take some public cloud. So that is called hybrid. So the thing is, when you have everything on private, on your data center, that is your private. And when you have everything on public, that is your public. And if you have a portion of it on private and a portion of it on public, that is your hybrid model. And if you really see the benefits is like in the public model, you will be having only operational expenditure. You don't have the capital expenditure. That means you don't need to invest on your equipment, and you will have what do you call? You don't need to own your data centers. You don't need to maintain your IT staff. So it will be easy for you to shrink and expand. All the benefits you will get, and you don't need to put any, because data center is not a simple thing, right? You need to invest in land. You need to purchase. You need to have enough power. You need to have enough cooling. So you need to get rid of all these aspects when you really go with public. But the thing is, you will not have more control, and your data may be pretty much in a situation where it can be shared with other these things. So generally, the cloud providers will make sure that these data will be secure and sensitive, but some of these banks and all these institutions will have their own apprehension. So typically they don't venture into it. But in the case of private, what happens is you need to still invest on your investment, land, data centers and all that. You still need to have your IT people taking care of things. And you need to still, take care of your aspects. So this is definitely better when you have a lot of government influence. If government says that, hey, your data should be within your, your data should be within your country, because you might have heard about data residency regulations. Even I think government of India is also talking about it, right? So the thing is, data which is created here should not be taken away. It has to be stored within the country, right? So those, if there are certain regulations like that, so the private data center will make sense, because your data center will be more regional, and it is more within your country's boundaries, and you'll be able to get into all those regulatory compliance and all that. So these are the different cloud deployment models we can see. And there are some other variants. People also talk about community model. Community model is like industry specific. Say, for example, some industry, some group of companies are working on, say, compliance or security. They themselves can form a community cloud, and they can do some research and some work on those areas. So, but the main models, what you can see is private, public, and hybrid models, right? So as I mentioned, if you see the bullet below 2 points, with private cloud, you will have more control, and it will decrease when you really go to hybrid, and when you really go to public, your control will be completely at the hands of the cloud service provider. And if you look at the scalability also, scalability means how quickly you can scale and handle more load. That can be low with private, but with public, you can do it very easily. So those are the two important aspects on the deployment models. And if you, any questions so far, guys? I know I'm just, we lost some time in between, so I was just rushing, but you can just stop me. We have a lot to cover. So Kiran, anything specific we need to address? Any questions?
No, Sharath, I tried to address all the questions except a couple.
Okay.
Those are regarding the confirmation of attending training. They are expecting a mail.
Okay.
Vishnu can answer those two.
Okay, perfect. So coming to the next part is the services, right? So cloud services, service models, we have 3 models typically. If you can see, there are 4 blocks on my slide, but the first block is more of whatever is there today, which is a traditional model. But if you see the other three models, infrastructure as service, platform as service, software as service, what exactly is? Basically, it is how much the level of control you want to give, right? That is what these three will talk about. If you see the on-prem or traditional model, the control is completely with the organization. So the thing is, they need to procure the what you call hardware, they need to procure servers, they need to take care of development, applications, operating systems, data, everything has to be taken care by the organizations. But when you come to the infrastructure as service, in the infrastructure as service, what happens is your hardware part, networking, compute, all these things will be taken care by the cloud service provider. And they will provide you that, okay, these are your virtualization, these are your compute instances or servers. Now you can do whatever you want. And these are your storage, you can do whatever you. So what you will be doing is, you don't need to worry about setting up OS, setting up hardware, configuring things and all that. That all will be ready-made given to you. So you need to do, what you need to do is, you need to use that platform, you need to develop your applications. So that means you need to still have your, if you are using a WebLogic or if you're using a Java, if you are using a database. So you need to get all those things installed, and then you will be able to develop your applications as per that. So that is your infrastructure as a service. So if you go to platform as a service, it will ease some more of your work, in the sense, in the infrastructure as a service, you are getting only infrastructure. In the platform as a service, you will also get your development environment. In the sense, today, it is not only sufficient to have my operating system, my hardware, my networking. I also need to have my development environment. I also need to have the database installed. I also need to have all my configuration set up such that my development environment talks to all these various, be it WebLogic, be it database, and I need to have my development environments. So all that aspects also taken care as part of platform as a service. So you don't need to worry about, you just need to go and code. That's it. You open your editor, you type your Java program, and you probably create your jars, and you can deploy it and you can run it. So you don't need to worry about so many of these development, what you call maintenance activities, be it your even your source code control. And you don't need to even worry about a lot of these things, because when you really do the development, it is not only coding, right? You need to also maintain your source code. That also will be taken care by the service provider. You also need to take care of your security, right? That also will be taken care. And sometimes you may be using some third-party libraries, or you may be using some open source. So when you are using third-party libraries and open source, what happens is these third-party libraries keeps on upgrading. So as and when you get a latest version, you need to make sure that your library is upgraded and tested with the application. So you will be manually doing all those things. But with platform as a service, all those things can be taken care behind the scenes, such that you will be exclusively focusing on putting your business logic and putting your application into action, right? So application and data is what you need to worry about in the platform as a service. So coming to the software as a service, it is like a full-fledged application given to you. So basically, you just need to use the application. You don't need to even develop. The application is already developed. Like for example, if you take any of the enterprise software applications, for example, there are so many HR applications, or so many supply chain management applications, so many enterprise resource ERP applications. So all these applications are fully functional. So you will be provided with whatever the user credentials. You will be provided with an administrative credentials. You can create your users. You can add your other employees, and you can start using the features. So it is a full-blown software developed and given to you, and it is your just responsibility to access and use it, right? So it is same as today we are doing Zoom, right? Zoom, we are just, it's a software which we are using. So here Vishnu has created his administrator. So he created the participants, he made the participants, what you call in some mode. He made me as a, what you call panelist. I can speak, I can show, share my screen. So he's using it. So he didn't develop this, or he didn't bother to develop this application, but this is already given to him directly, right? So that is your software as a service. So in cloud, you have options to take either of these models. And the thing is, it depends on the individual organizations. What kind of, if an organization is really developing something customized to that organization, they may go for platform as a service, as that they have that flexibility to develop. So if you see the bottom points, flexibility will be more with IaaS because you'll have control on OS, application runtime, and the application comes down when you really go to PaaS. And if you really go to software as a service, you don't have any control on the flexibility part, right? Similarly, level of abstraction, I think with SaaS, it will be more abstracted compared to PaaS and IaaS. So these are some of the cloud services which you can see. And the last slide I have is about, on this particular thing, is on the Magic Quadrant. So you might be wondering, what is this Gartner? What is this Magic Quadrant? And why we need to worry about this? See, for example, I am owning a company. So now I want to I want to go for cloud. So now if I go and Google on the cloud, I can see a lot of players. I can see Amazon, I can see Oracle, I can see Microsoft Azure, I can see Google Cloud. Like that, we have so many cloud options. So now I'm confused. So what is that I need to do? Which one to pick? So I need to know who are all leaders in this area, right? So Gartner is one of the research analyst company which does research on these things, and they will do all the research, and they will tell us, hey, these are the top 5 companies, top 6 companies, top 10 companies who are doing good. They are strong in these areas. They are strong in these areas. So the thing is, it is not like because some companies may be strong in servicing platform as a service, right? And some companies may be strong in IaaS. Some companies may be strong in, say, software as a service. So then the selection has to be based on what my organization needs. So basically, I'll go and check this Gartner Magic Quadrant. This they will do it every year, and whatever I'm having here is basically from July 2019. As for this, they have these 6 players who are the leaders, and how they will be choosing this means they have this quadrant. So this quadrant is basically, they say that there are 2 x-axis and y-axis, right? So completeness of vision is, so they think about, okay, what is going to be the future? So if they have that clarity for the next 5 years, so these are all the things I'll be changing. These are all the innovations I'm going to bring. So that is the kind of vision they have. That is what is the x-axis. And if you go towards the right, that means they are more mature. They have more clarity on the vision, is what I can say. And towards the left, we can say that they are just started. They are just coming out, thinking about it, is what you can say. That is the reason. Niche players and what you call visionaries. And if on the y-axis, you have the ability to execute. In the sense, like, you have the challengers, you have the leaders. So basically, if you see logically, what happens is whoever comes towards the top right, they will be the ones who will be the top. So whoever comes in the leaders, some people may come in challengers, because they may have a strong ability to execute, but they don't have a vision to the future. So they may become a challengers. So something like that, these players can be segregated and all that. So I can probably, I have this weblog, what do you call the web URL. So I'll try to see if I can quickly show that to you. Let me see. Yeah. So if you see my screen, that is the same URL I used. So this is the major Magic Quadrant for cloud infrastructure as a service worldwide, right? If you see here, this is published in July 2000. This is publicly available. And so you may be wondering I can show you the quadrant will be, it looks like this. So if you see here, see, you can see Amazon, Microsoft, Google, they are in the top quadrant, and you can see Oracle, IBM, Cloud, Alibaba on this block. So the thing is, it is all depends. So you may be wondering how they decide on these things. So for this also they have every vendor will be assessed based on certain parameters, right? For example, if you see here, they are basically checked on offerings, right? What kind of offerings they are doing, and they can check on the geographical spread. They can check on the company profile, and they also assess and put you what are the typical strengths, what are the areas of caution. So this is the way they try to do a research on these things. So as an organization, I will review these things and I can just decide, okay, so I can probably go with, say, Google Cloud, because Google is strong on the platform as service, and that is what I am more interested in. And similarly, I can say that, okay, I'll go with Oracle because Oracle is good in enterprise software. So it has a lot of SaaS solutions. So I can go with Oracle. And similarly, if I'm looking for infrastructure, then I can say, hey, Amazon is really doing good. So let me go with Amazon. So this is the way every organization can take a call based on how these companies are positioned. And if you see, these are some of the parameters on the product or service and the overall visibility from a product standpoint, from a business standpoint, from a financial standpoint, from a sales and execution standpoint. So they were measured based on these criteria to conclude that these are the companies we need to go with. So I thought this will be helpful for you to understand that, okay, this is the way these things will go. So that's the reason I just thought of showing it to you. So this ends my second portion on the cloud computing, which is about the concepts of cloud, why cloud is important. And we also discussed about the infrastructure, the kind of wastage we are seeing on the infrastructure, how the virtualization is helping it. From virtualization, we targeted how these data centers have evolved into converged infrastructure, to hyper-converged infrastructure, and how all these features are taken over by cloud service providers, and what are the features the cloud service providers are offering, what kind of models we have, what kind of services we have, and what are the key players in the cloud service offerings. So these are all some of the introductory part for this particular session. So I'll take a pause here. Any specific questions which I need to talk, Kiran? Kiran, you there?
Can I chip in here 1 second? So I want to address few of the questions. So yes, there is a feedback link. I will be giving the feedback link at the end of the session.
Okay.
And also, guys, there is no participation certificate, but you'll be getting a confirmation mail from our end, which will include the presentation slide as well as the recording. You'll be getting the whole webinar recording as a YouTube link. So you'll be getting both in the confirmation mail only. And also, let me know when your session is about to end. I'll just show them to, talk a few about remote internship program that to offer. Okay, over to you, Sharath sir.
Okay, thank you, Vishnu. So I think hope you guys are with me so far.
Sharath, there is a
okay
question.
Okay.
We got a question from Meenakshi.
Okay.
The question is that, please explain security issues, challenges, and cloud attacks.
Yes.
Cloud security.
Yeah, sure, Meenakshi. So I have a slide where we discuss about the security aspects. There is one slide. So can you please hold your question till that point? Okay. Yeah, thank you, Kiran. So I'll just talk about it when we really get onto the cloud architecture. Okay. Okay, so now the next thing is, now we understood the cloud concepts. So now you may be wondering how we can deploy, what is this we are seeing a lot of buzz on the Docker, Kubernetes, containerization, and whenever we talk about cloud, people talk about all this terminology. So how this is relevant, and as being the engineering students probably doing development, you may be having all these questions lingering in your mind. So let me just spend some time on this before I jump onto the cloud architecture. So the containerization in Docker, before even I jump onto it, the important thing you guys need to remember is earlier, no, we used to have only monolithic applications, right? Monolithic applications means what? You used to develop the applications in its entirety. So for example, you developed one application and there was an issue, there was an outage, or the application got crashed. And the issue was very small. Say, assume that you missed a comma or a semicolon in the syntax, but still, no, I think when that particular function is invoked, the application crashed. So what is happening? So you have to bring the complete application down, you need to fix it, and then you need to release a newer version, correct? That is your typical monolithic, what you call stand. But this was realized by Netflix in 2008 or 9, I remember. You can Google for it. So they are the ones who pioneered this microservice architecture. So the thing is, the microservice is basically reducing that risk, in the sense, if there is a small issue, limit that issue to that particular area rather than bringing the entire application down. That is, in a plain concept, microservice is nothing but that. In the sense, I will separate my application into small microservices. Each service is independently developed, can be independently tested, can be independently deployed. So these are the important criteria you need to remember. So that way, what happens, say for example, my application is say 100 combination of 100 microservices. So if all these things are developed independently, they can be deployed. There is no, the kind of dependency is limited. Even if there is a dependency, the dependency can be through some API calls and all that. So then what happens, if one of my microservices is having this comma issue or semicolon issue, then I can only just bring that service down. I don't need to bring the other services which are getting used by other customers, right? So that is the paradigm shift we are seeing from monolithic applications to the microservices, what we are doing today. Hope that is clear for you guys. So with that, let me jump on to the DevOps. Even I think you might be wondering why we need to talk about this DevOps when we really talk about Docker containerization. Means I'll tell you. See, any application in its life cycle has to go through first the development, then the QA, and then once the QA is done, we will put the application in the production, and from there the business starts using that in the production. And when there is some issue in the production, there is immediately some operations team who will be knowledgeable on the product or application. They will be helping on fixing those operational issues. And if the operational issues are leading to some code change or defect, that will be pushed back again to the development. So this is the typical cycle. So often what happens is, though we do all this development testing and all that, we see a lot of issues in our development, and we keep seeing a lot of blame game between these teams. So in the sense, say, operations or the business may say, hey, what kind of testing you did? Why you didn't catch this issue early in the game? So these are some of the things which we often see in our development, in our products. So some of the reasons why this happens is, first thing is our development environment, our QA environment, our production environment, they are slightly different. Because typically when a developer, because of his ease of use and all that, they develop in Windows, right? And when QA is testing, QA will be testing, say, for example, on the Linux machine, because they think that, okay, Linux is more closer because, say, the business may be using it in some different variation of Linux or Unix, but the QA will be testing in that particular environment. But the thing is, the QA environment may be limited in terms of the loads which they test and the data they have, because the test data will be very limited. They may not cover all scenarios and all that. So the thing is, again, QA will be able to do only to some extent. Then what happens is, it comes to probably it will be validated by performance, for performance metrics and benchmarks. Then it will be put on the production. So this way we have a difference in the environments also. So that is one reason where we see some issues which we didn't see in our QA setup will be caught in the production setup. So those are the things we need to see how we can, what do you call, streamline and make it unique, in the sense like nowadays people are talking a lot about creating the same kind of environment for development, QA and everybody, such that they can test the same kind of image or same kind of application environment, such that any issue which can be seen in future can be seen now itself, right? So this DevOps is more of a shift in the culture and the mindset, in the sense like the collaboration is also one important thing, in the sense like earlier, they used to work in silos. The development is development, QA is QA, operations is operations. So as they are working in silos, so these people may not be knowing what the other teams are expecting. But now what we are seeing is we are seeing a change in the shift. And even I can remember, like in one of my experiences with some customers, we used to have every new application development, there used to be a architecture review phase and also a design review phase. So in the architecture review phase and design review phase, we used to pull the operations teams. So they used to put these questions, like they used to think more from a production standpoint. Hey, okay, when this load crosses this, how you will handle? Or when you get your data like this, how will you handle? Because they have a lot of experience with the real world data, real world scenarios. They used to pose those questions early in the game, such that we used to understand them during the design and during the architecture phase, and we used to address those things to the extent possible. So DevOps is more of converging all the teams together, build that collaboration, and identify and address the issues early during the architecture and design phase. So that is what is typically the Dev and Ops. So if you see here, right, the development typically plans, creates, verifies, packages and releases, and it can be configured, monitored. And again, whenever there are, when you are monitoring, you may see some issues, and this will again go back to plan. And if there are some enhancements or fixtures, this cycle will continue, right? So that is what the intent of this particular slide. So now coming to containerization, what exactly is containerization? So we already discussed about virtualization, right? So the block on the left side is talking about the virtualization. So in the virtualization, what happens is you will have your physical hardware, you will have your host operating system. And on top of this, there is something called hypervisor, which is nothing but like an operating system, but operating system more for virtualization. Okay. So what this hypervisor will do is, see, for example, it will try to virtualize your hardware. What do you mean by virtualizing the hardware? Means, suppose you have, say, 32 GB of RAM, or probably you may have 1 terabyte of hard disk. So it will take that hardware, it tries to virtualize, say that, okay, probably out of 1 terabyte, take 200 GB for application or virtual machine 1, and say 300 GB for another virtual machine. So, and if you see here, the virtual machine 1 is running on Linux and virtual machine 2 is running on Windows. So the thing is, the same physical machine, the same physical hardware is split, for one for Linux and one for Windows. So how that is possible is that the hardware is getting virtualized with the hypervisor. So that is what is the benefit here. But still the challenges with this virtualization is, still there may be some what do you call, inefficiencies with Linux and Windows, in the sense like the Linux may still have whatever that particular application may not be using the things 100%. Similarly, the Windows may not be using the resources 100%. And one other thing is, these are heavy. The reason why I'm saying them heavy is they are completely carrying the operating system. When you say you are carrying an operating system, is there is lot of operating system specifics like your kernel and all that, right? So that is the reason this will become heavy. So the alternative option for us will be a container. So a container is, we don't want to take multiple operating systems here, because say for example, as I mentioned in my prior slide, right? I want to test my application same in both development, testing, and production. So I want to use the same underlying, say, Linux operating system. So for me here, I don't need to worry about carrying the operating system overload for each and every application, because the operating system is going to be same. So what I'll be only worried about in this container is, I'll be only worried about the application specific libraries, application specific any other dependencies which I need to worry about. But the underlying operating system kernel will still remain the same. So you don't need to duplicate that, right? So that is the beauty of this container applications. And the thing is, it can see, it is a unit by itself. So the thing is, it can run anywhere. In the sense, you can run this container anywhere is one important thing you need to remember. And this is similar to, I don't know how much you read about these containers. These containers, if you read, this is more relating to your shipping industry. And the reason why they put this name Docker containers means the way this containers concept evolved in shipping industry is because the goods can be transported through multiple means. In the sense, say, suppose the goods get manufactured in a factory, and from factory probably there may be some goods carrying those goods first to say some place. From there, a truck or something will be carrying again to probably say a seaport, and from port it will be shipped into a ship. So everywhere these goods has to be ported from a train to a bus to a ship, right? So for doing this transportation, there need to be a consistent uniform way such that that can be easily transported and executed anywhere, right? It is the same thing. This container will be same. This container will operate effectively anywhere similarly, and they're all unique in nature. It contains everything. It contains the operating system kernel. It contains the binaries. It contains whatever the application specific dependencies. So you can look at each container as one microservice here, right? So it can be built, it can be tested, it can be deployed also. So that is the key difference here. And what you need to remember is this container can make the job easy for us. And suppose if I have 100 containers, say representing 100 microservices. So if I want to say, for example, 2-3 microservices are more in demand, so I can only scale or probably make these more containers available to cater to the demand for those 2 containers. For other containers, we don't need to, right? So that kind of flexibility we can get with the containerization. So hope you guys are clear with virtualization and containerization. So then you may be wondering what are the ways and means of implementing these containers, right? So there comes the answer in the form of Docker. So Docker is again, which is an open source, and a lot of these industry organizations contributed a lot. And basically what it does is it helps you in, so a Docker container, how it can be evolved, how it can be created means a Docker, first what you will do is your code will be there, right? So your code will be translated into a small Docker file. It can be, say, assume that it is a small text file, right? So when you really give this Docker file, a Docker image can be extracted from the Docker file, okay? So image is nothing but like a schema, right? So, and you know, right, in the database, we have schema, and every schema you can, what you call, come out with instances and all that. Similarly, Docker image is like for example, if you have learned object-oriented programming, So you will have a class and objects, right? So your Docker image is nothing but your class, and your Docker container is nothing but your objects. So now the other important aspect is when you have all these Docker containers, like probably thousands of Docker containers in the environment, who will be coordinating all these things? Who will be knowing when to scale some containers, when to shrink some containers, where is the demand, what kind of configurations required, how you can ensure the compatibility, and how you can ensure these API calls. So all that will be taken care by an orchestration platform called Kubernetes. So Kubernetes is the one which will manage and maintain all these containers. It is more of it operates more in a clustered mode and will have all these. So basically how it works is Kubernetes contains something called a node. Node is something like a server or an instance you can call. And in that node, you will have, because node means you can cluster the nodes, right? And each node will have something called pods. So pods contain one or more containers. So that is the way they're all organized. So, and there will be multiple nodes. So that is the way I think. So sometimes you may have one container per pod and one pod per node. That's what. And similarly, sometimes your pod may have multiple containers and you may have multiple pods. So all those combinations are possible. But one thing we need to remember is these containers can be clubbed into a pod only if they are related. If they have some common or sharing or something related, right? If they have some tight or some close coupling, then only those will be combined together. But otherwise, they all will be separately maintained, right? So this is a quick snapshot about the Docker and the containerization. So, and I think I have my colleague Kiran also in this call. So Kiran is very actively implemented a lot of Docker images, and we typically do day in and day out on these Docker files. So Kiran, you want to share a few experiences from your side?
Sure, Sharath. Thanks for the opportunity. Okay, as Sharath already explained, Docker is a open platform for development, shipping, and running the applications. Of course, it's the most widely deployment tool nowadays. So I would like to give one of my experience. So we have implemented a product for one of the bank, and which has a presence in 14 countries. So initially, what we did is we set up the customer environment through manual steps. So that took around 45 to 60 days, because this implementation is little tough, because it involves a lot of configurations. So it took long time, and another problem was that we delivered the installation document to customer, and right, customers are are not sound technically. So there are chances of doing some mistakes, and we have to chip in and debug the problem. So it took around 45 to 60 days. So later we realized that manual installation is not going to work out. Then we have provided automation scripts to deploy the application. With the automation script, we were able to deploy the application in 2 weeks. But the challenge here is, it took around 4 to 6 months for us to develop the script. So it's a big effort. 4 to 6 months is a big effort for developing the script. And again, we were able to automate only 90% of the application deployment, because 10% we didn't find any suitable script. So there are still some manual steps involved there. And another important point here is, again, the script has to be executed by the customer. So we have to again give the the detailed document how to run the scripts, and how to configure the 10% remaining manual steps. So now again we are changing our approach. and we created a Docker image. So with the Docker image, the customer is not at established environment with that. But my experience in our local environments is that it should not take more than 2 to 3 days. So see that how drastically the timelines has come down. Manual installation is 45 to 60 days. Through automation scripts 2 weeks, and through Docker image it's only 2 to 3 days. And it's not only the 2 to 3 days deployment time. To develop the Docker image also, we didn't took much time. We spent around around 45 days to 60 days. That's it. Again, this image is as Docker is platform independent. So customer today is is running his application on a particular version of Linux. Tomorrow he can run it on different version of Linux, but no need to bother. He has to compile the image and he has to restore the image. It's really what I can say, time saving tool for us as well as the customer. That's my experience. And coming to the development, it's customer experience. Coming to the development, we talked about CI/CD, right? The continuous integration and continuous deployment. During every phase of development, we can build the Docker images and we can deploy it and we can test quickly, and any issues we can go back to development within no time. That helps for CI/CD effectiveness in the development organizations. So that's why it's so popular and most widely used tool in nowadays. Any questions? Please feel free to ask. We will address.
Yeah, thank you, Kiran. That was a nice this thing. So guys, one thing you need to remember is, yes, there will be some one-time effort in learning it in terms of scripting and all that, but I think it is quick. So I know Kiran mentioned some number of days to develop our first image, but that is only first time, right? Next time when he developed the same for other applications, it was quick because we already had this learning. So we can do it anywhere from a week to 10 days, 15 days, we can get these things in up and running. So the thing is, the quick rapid development is definitely one of the key benefit from this Docker. And one other thing which I want to highlight is, you may be wondering where I can get these Docker images. Can I use Docker image of some other thing? Suppose if I want to download some operating system or application. Yes. So we have something called typically, every organization, they may maintain their own Docker hubs where all these images will be there, and every team can probably put these images and they can reuse and all that. And similarly, overall also, we have some Docker hubs where we can upload our images such that others can pull and others can use also. So that kind of reusability is possible with the Docker. Okay. So it can definitely help in the rapid application development time. So the thing is, why this particular topic is important is, for cloud, when you want to do things so fast, you need to also develop things fast. To develop things fast, what is required is all these capabilities, all these change in our thought process, change in our mindset on looking at development, QA, operations together, converging. So these are the definite aspects which can help in the rapid application development, right? So this is the end of this particular topic of containerization and Docker. So before I jump on to cloud architecture, Kiran, any questions, pending questions which we need to address?
No, Sharath, I don't see any new questions.
Okay. So yeah, keep an eye on them, and you can answer them on the chat, whatever you can. And if there is anything pending, we can review at the end. Okay. Okay, guys. So now I think we have 2 more topics to cover, I think, to take this to a conclusion. So this is an important aspect. So you may be wondering, okay, now we discussed a lot about the features of cloud service provider or cloud deployment model, services and all that. So, but you may be wondering how these Amazon, how this Oracle, Microsoft Azure, how typically they work. So how can they deliver these services? So what kind of model they have? So that is something we will try to look into it as part of this cloud architecture. Sorry. So one thing you need to remember is cloud is nothing but anywhere, anytime, right? In the sense, an Amazon service provider can provide a service to a person sitting in Hyderabad or a person sitting in California or a person sitting in, say, London. So the thing is, for them, they need to have a presence everywhere, correct? So that is the reason every service provider, be it Amazon, Azure, or Oracle, or whoever, they all will create some hierarchy in terms of how they will facilitate the services. So the first level is your region. So they will call it as, say, you can call it as Asia Pacific or North America, and within North America, you can probably distribute it as North America East, North America West. So regions is the first level in the hierarchy. This is basically the topology or hierarchy or whatever you can say. Then comes the availability zone or availability domain. See here, the terminology I am using is not specific to any provider, because some service providers use availability zones and some service providers use availability domain. So the naming is something which I tried it to be generic, such that you can map it easily whenever. If you read Amazon also, you can map this, or if you read Oracle also, you can map this. Okay. And each domain, availability domain or zone will also have, again, some logical data centers. So then you might be wondering, what is this region? What is this availability domain means? You just look at it as availability domain or zone as a physical data center. Okay. And physical data center means the way you have all the software, hardware, and your cooling, your infrastructure, your position, all that will be all the physical data center, whatever you can say, that is you can consider it as your availability domain or availability zone. And as we have seen in our virtualization conversation, we told that we can virtualize anything. We can virtualize a network, we can virtualize a compute, we can virtualize anything, right? So taking this physical availability domain, you can create logical groupings or logical data centers. That means I can take small set of compute storage and I can create one logical group. And this way, what you can do is you can use all this for fault tolerance, in the sense like, suppose in this diagram on the left side, say if at all, if I have some application running, I can put my application on the first logical data center as well as on the second logical data center. So that means by any chance, if first logical data center goes down, I think your second logical data center is still active and you will have your application still running. Then you may ask, okay, Sharath, you're saying this fine, but say what happens if both the logical data centers goes down? So then what happens is I will go back to, say, availability domain zone, and there may be some link to my, I didn't put a connection here. I may be having another what you call link to my, so you have redundancy at all levels, in the sense you have a redundancy at the availability domain level, you have redundancy at the logical data center level, and you have redundancy at the regional level also. So that means even if you are failing at one level, there is one more level, there is one more level. So that is the way we will try to ensure that the high availability is something which is always possible. So this is my first part on the cloud service provider. The regions, then comes the availability zones, then comes your logical data centers. Then let's talk about all these things individually. So I'll come to each one of them. So you have compute, you have, if you come from bottom, you have regions. Regions, as I was telling, you have all these various regions, and physical network is all your equipment. But physical network, you will be virtualizing and you will be getting a virtual network. And that virtual network will be useful to virtualize all the, whatever the compute storage, whatever you are virtualizing, that can be communicating over these individual virtual networks. So this diagram is trying to talk to you or show you that the region, the physical networks getting virtualized, and these virtualized networks will be helpful in what you call facilitating the communication between the virtualized computes and virtualized storage. So I'll not probably get into little more on this. Anyhow, in the next slides, we will talk about them. But this is the typical layout of your any cloud service provider's setup. Okay. Okay, let's start with networking, right? So when you see the networking, how these networks work, right? So again, I don't want to complicate this. I just put some 2-3 points here. Just assume that let's think about a small application to be hosted, and say that application has to be probably talking to another application, say application 2, application 1 and application 2. So what I will do is, and I want my application 1 and application 2 to be having separate ports, and they have separate permissions and all that. So what I'll do is, every network, I think you are all engineering students and you might have read in the networking. So your network, if you take any IP address, you have 4, right? X dot, X dot, X dot, X. So you all know, right? These 4 will have 4 meanings. The first one is your network. The last 3 will be your subnetwork. And typically the last number will indicate your host. That means exact device, right? So your network, your subnetwork, and your host address. So these are the 3 things which are embedded in your IP address, right? So what I will be doing is, for my 2 applications, I will create 2 subnets, okay? So subnet 1, subnet 2. And once I create the subnet 1 and subnet 2, I also need to tell, because I want these subnets to be identified. So I will be having something called IP addresses. And it is not just IP addresses, it may be a range of IP addresses. So then you might be wondering, for one subnet, why we need many IP addresses? The reason being, in a subnet, you can have your compute, you can have your storage, you can have your multiple devices. And each device has to be identified with an IP address, right? So every subnet will have a set of IP addresses which can be parked or reserved or masked to be used for these individual devices, right? Then what is the firewall and security means? When you have this instance or all this storage sitting in a subnet, you cannot allow every traffic to come into this. So you want to say that I only want to allow the traffic, say for example, coming from some port, or targeting to reach to some port only I want to allow. So those kind of firewall and security rules can be defined at the subnet level. So again, no, some vendors call it as security group, some vendors call it as security list. So these are basically the security rules which you will be defining, such that you can control your traffic. What traffic can go out from this subnet? What traffic can come into this subnet? So that is part will be what you call controlled as part of the firewall and security point. The third is route table. Route table is what? Suppose from your cloud, if you want to send anything outside, say for example, you are sending some data to internet, or say if you take a hybrid cloud model where the on-prem or on-prem data center is active, as well as your cloud setup is active, and you want to communicate from your cloud to your on-prem data center. So you need to have some kind of gateways, either to talk to internet or to talk to your on-prem data center. So all that can happen with the help of route table. So what basically you need to do is, you need to put your entries in the route table. Hey, this particular instance has to send some data to so and so. This is its gateway. This is its IP address. So that way, whenever the traffic is emanating from the IP address or from that particular instance in the subnet, it will definitely allow the traffic to pass through, right? So you are clear, right? So one is definitely your IP addresses, and the second is your security rules. The security rules are to control what traffic to come in and what traffic to go out, and your route table is to control the communication with the external world or with your data centers or with your internet, other applications. So that is your gateways. So I assume things are clear so far. Let me move on to the next slide. This will probably make it little more clear. So this diagram I just hand drawn with my yesterday, just to show this to you guys. So if you see here, the bigger box is your cloud region, right? And you can see the availability domain is within that, correct? And within that you have your subnet, the smaller box. Within the subnet, under that you have that the one with boxes, that is your instance. Instance can be anything. It can be application, it can be any virtual machine, whatever, right? And if you see, that subnet is tagged with two things. One is your security rules, another one is your route table. So if I want my my instance to talk to, say, database, right? So I need to open, say, for example, if it is Oracle or whatever, right? There is some port, I don't remember, it is 1231 or whatever. So we need to open that port such that this instance can talk to the database. So that all can happen in your security rules. So this is where you will be updating a rule saying that, hey, allow this instance to send the traffic to the database. So that entry has to happen in the security rules. Similarly, I have another option here called, this is a gateway. So this NAT gateway is something, this is a special kind of gateway which only allows the resource in the cloud to communicate with the external world. In the sense, say, for example, say here my database is, say, Oracle. So it is, say, for example, it is on Oracle, some version, 18C or 13C or whatever. So I want to see that whenever Oracle here is updating the versions with more patches, right? I want that patches information to come to my database, right? So for that, what I will do is I'll open a NAT gateway and I'll made an entry in the route table saying that allow the traffic from this database to go to this database vendor and fetch the updates. So this is a controlled gateway such that if Oracle want to send or any other vendors want to send any traffic to this particular thing, they cannot do. The control will be more with this. So whenever it wants, it can send a request and it can get the upgrade. So that is the NAT gateway. Similarly, we have other gateways, like there is something called internet gateway. When it is an internet gateway, then there should be another entry in the route table and it should be able to go to internet, but that can be bidirectional. When it is an internet gateway, I think it can allow you to it can allow the external sites also to send information to this particular instance or database, right? So typically when you say, the good example for that will be when you host a web server here as part of your instance. So web host, and you put your web application, then you need to open an internet gateway. So that way, when I am submitting a request from my internet, it should come and hit this particular instance. Similarly, I should be in a position to send the response back. So when that is the case, then that internet gateway, there should be an entry in the route table. And the ports part can be entered in the security rules list. So this is the way the communication of within as well as to the external world happens. And similarly, there are multiple gateways. So if at all, there is a gateway which can help in communicating with the on-prem. There is a gateway for internet. There is a gateway for NAT. So like that, we have multiple gateways to interact with the external world. So this is a bit about compute. So I just take a pause. I know this is too much of information. So any questions, Kiran?
No, Sharath.
Okay. Yeah, moving down. So we have storage. right? This is the another important piece. So storage can be again block, object, file. So typically storage is nothing but your unstructured data, right? Be it your videos, images, logs, all data. So all these data runs in bigger volumes. So that is again one advantage with the cloud. So you can have a lot of storage available, and you have block storage where you can think about big databases, data warehousings, and your boot disks. All these things can be covered as part of block. This is more like a disk. It gets to that sector level and all that. So block, the reason why they named it as block is they will say each block will be of say 512 KB or some number will be there. Based on that, it will be taken, read in chunks. That way, it can be faster. And you have your file systems. So this is the big, it can accept bigger, right? So in the sense now you have a situation where you have your on-prem, you have your cloud, and if you want to have your data getting stored, and if you want to really share this data across on-prem and cloud, so file storage is one option. So, and there are some gateways for that also, like storage gateway is one important concept where you should be in a position to mount these file systems, and then this file storage can be leveraged across the what do you call applications or across the systems. So this is a bit about storage. And one thing you need to remember with respect to storage is the data can be encrypted. The data can be encrypted in when they are at rest, and data can be encrypted when they are in transit. In the sense when the data is moving between systems, that can be encrypted, and even when it is in the system also, it is encrypted such that no other unauthorized access is possible or feasible here. So this is a quick snapshot about the storage. So before I jump onto this, so this is a quick snapshot about the cloud architecture. So we have seen about compute, we have seen about storage, we have seen about networking, we have seen about how all these things will interact, what is subnet, what are the various ways you can control the IP addresses in the form of security rules for allowing or not allowing certain IP addresses. And you also have route table, which can allow you to interface with the external world through gateways. So these are some of the typical concepts you come across in any cloud architecture. So if you take any service provider, these are the general common concepts which you can come across. Okay. So before I jump on to the next topic, any questions, Kiran?
No, sure.
Okay. So coming to the next interesting thing is pricing, right? So pricing is always an interesting thing. So first question people have is, no, I already have a license for say WebLogic, or I already have a license for Oracle. So what happens if I come to cloud? Means there is one thing called bring your own license. So you don't need to again spend money on that, right? You can bring your own license for that product. That is one. And in the beginning, I was telling you, right? Pay as you go or on demand. This is similar to our utility bill payment, be it your water bill or be it your electricity bill. So the amount of compute you use, the amount of storage you use, you will be paying only for that. Okay. And most of the times what happens is there will be a lot of freebies here. Even for certain things, the traffic sometimes within the same cloud setup, you don't need to, for communicating, you don't need to have any entry in the route table because you don't need a gateway. But still, you definitely need the security rules. In the sense, even though they are in the same cloud setup, if my instance want to talk to a database in another instance or somewhere outside, so you still need to have a security rule which talks about the ports it can allow and all that. So without these entries for the ports and the IP addresses, you will never be able to establish a connection, even if you are in the same infrastructure. So basically what I'm trying to say here is everything is as per your usage and as per the time you spend. So pay you as you go is that. And there are so many other models also, like sometimes they do it as a monthly or yearly subscription, because it depends on, because anytime, no, once you put, because you also see, right, whenever we go for a monthly subscription, yearly subscription, you'll get more discount, because for an organization that will be more money at one time, so they can give a discount of say 5%, 10% and all that. Similarly here also, if you take a subscription model, and if you know that yes, I definitely need this much of usage on my resources, you can go for a yearly subscription or whatever, and you will get very good savings. I think even I can say that the savings can go from 20% to 50-60% is what people say. Again, it depends on the resources, what kind of resources you are using and all that. So so other way to look at it is the pricing can be also depends on the type of processors you use, because if you are using some costly processors, or for example, if you are using some high performance compute, or if you are using something like a Intel processor, so it varies. So the thing is, it is based on the cost and based on the resource type you are choosing is definitely the important thing. And also your cost also factors in the data transfer, whether the data is locally transferred or whether the data is getting transferred across the regions, across the availability domains, or from cloud to data center or cloud to on-prem. So all those things will help in defining that, okay, the pricing will be based on this. And similarly, if you are really looking at high performance computing, the prices will differ. And if you are using bare metal is nothing but you will just get the hardware, that's it. So if you are only looking at that will be a different these thing, right? So depending on the use case, depending on the number of resources, so it will vary from organization to organization or user to user. So that is the way I think we should look at it. And one other important thing is, sometimes, no, even some of the organizations go with what you call auctioning the available space and available compute and all that. What do they mean by auctioning is, so I think they already have used their capacity and they still have say 30% left, and nobody is subscribing. This 30% is lying there vacant. So instead of wasting that, what they will do is they'll put it for an auction, and whoever gets a good price, they will give that that capacity to that particular organization. So the auctioning is one more way of, but auctioning is not structured. It all happens based on the capacity available and all that, and it can be for a shorter duration and all that. And like cloud is definitely one big thing for the people like you, because earlier, if you have some good idea, if you want to innovate, and that innovation needs infrastructure, so you need to buy a machine, you need to buy the corresponding infrastructure and all that. And if your idea is bombed after 6 months, this cost will be gone for a vain, right? Probably you got some learnings and education, but this infrastructure will be of no use for you, because if you invest more. But with cloud, what you can do is you can take say 3 months of subscription. You can just experiment with whatever the capacity you need, and whenever you are done, if it is successful, then you can venture in buying new infrastructure. If it is not successful, then you can definitely go with another option and all that stuff. So I think this flexible pricing will make anybody access to the cloud. Getting these things quickly, sharply, and all that is what is the biggest advantage. Okay. Coming to the cloud security. So I think, yeah, somebody, Meenakshi, you were asking about cloud security, right? So I can talk about cloud security in these 4 parts. First thing is the identity and access management, right? In the sense, everything in cloud is defined, very well defined by a security policy. So you need to define your security policies. So the security can be for your instances, security can be for your users, security can be for your administrators, everybody. Any instance, if the instance need to communicate with another instance, there need to be a security. Or if a user want to access a storage device, he need to have that access. So what we will do is, in cloud, the first step we will be doing is defining these permissions. So even these permissions can be defined at the region level, at the availability zone level, and at the instance level. So whatever level you can define. And it is so flexible that you can define generic or you can define a specific device. Say for example, in compute, I have say 10 instances running. Suppose if I want to define a security policy for all the 10 instances together, I can do that. Or if I want to define a security policy for a specific instance, I can do that, taking the name of that specific instance. So you can do these security policy definitions at all levels. So that is an important step for us. Without that, you will not be able to do anything in that particular portal. So for everything, you need to have a policy written, a security permissions provided and all that. And each policy will be tagged to a group. So I create a group. So groups can be, I can say, if I am a development organization, I'll say a developers is one group, a quality assurance is one group, my managers is one group, and I can then add users to those groups. So the thing is, first thing is your security rules or policies, and next thing is your groups. What I'll do is I'll map these security policies to the groups such that these groups can access those resources. Now I will attach resources, individual users to these groups. So this is the way all this the identity and access management thing works. That is first part. The second option through which we can ensure security is data protection. So I was telling you, right? So the data can be protected when it is at rest as well as when it is in transit. So it is all encrypted with all the latest encryption algorithms and all that. And you don't need to worry about it. So it is only visible and accessible to yourself, right? So that is an important thing, because this is very critical, because we are working in a multi-tenant mode. So I missed to tell about single tenant and multi-tenant. So single tenant and multi-tenant is like, if the same service, if the service provider is using multiple tenants, each tenant can be one organization, say company X, company Y, company Z. If these people are, if these three organizations are using one cloud service provider, they are operating in a multi-tenant model, okay, such that they don't need to worry about the physical machines, but they will only be worried about the virtual machines, and the virtual machines can be drawn from the same physical machine for all these three individual companies. That is what is your multi-tenant. In the case of single tenant, what happens is only one company, say for example, my one physical machine is having, say, this many virtual representations. So if I want to reserve these virtual to only one company, say all these three virtual resources can be used by only one company, then you can call it as dedicated or single tenant or whatever, right? So that is the way. So when you have a multi-tenant kind of setup, so this data encryption and data, this thing will give a lot of assurance for the end user. So that is an important point to remember. And operating system level, the security is very important, because you know, right, Windows or Linux, these releases patches every day because of security vulnerabilities and all that. So the cloud service provider is very prompt on these things. So they keep applying these patches, upgrades on a regular basis, such that no, you are protected. You are protected from any vulnerabilities from a security standpoint, right? The fourth level is infrastructure. Infrastructure is your overall cloud infrastructure. And sometimes there will be communication between multiple clouds, in the sense like, say for example, I want to test my cloud model. So I don't want to put all my eggs in one basket. So what I'll do is I'll put some applications on, say, one cloud vendor, and I'll put another set of applications in another cloud vendor. But these applications still need to communicate, right? So multi-cloud communication is required. So when you are having these kind of situations, you need to have a robust, what you call DMZ, demilitarized zone, they call it, or again, firewall rules at that probably infrastructure level. If you really have all these things, then I think we'll be able to restrict the unwanted traffic from each other, right? So that is, so enough safeguarding, enough these things is taken care at the infrastructure level. So The identity and access management is at your instance application level, you can think through, or resources level, and data protection is your data level. Operating system, yes, your OS level. Infrastructure is at your overall infrastructure level. So that is the way we will try to ensure the security at all levels, right? So this is what is my response to your question, Meenakshi. So you have anything you want to know more, Meenakshi? Kiran, did you see anything on the chat?
No, sure. I guess we are running out of time.
Okay, yeah, guys, I think I'll be almost there in another 5-10 minutes. We'll wrap up. I know like we got some disturbance in between, so it's taking a little long, but I exactly planned for that time. Okay, so without any further ado, let me move on to high availability and disaster recovery, right? These are two different things, because people always mix these two things, but I can tell you the difference. Disaster is when really a disaster occurs only, we'll talk about disaster recovery, right? So high availability is like when everything is fine, no disaster, nothing, but still no, your application may go down. That is one level. Or your availability domain or your data center may go down, or your region may go down, right? So at all levels, you can protect yourself in the sense, if your say for example, your instance is what you call grouped in 1, 2, 3 logical data centers or fault tolerance groups. Then what happens is, even if one instance is down, you can definitely use the other fault tolerance to pick it up, right? And that is the way you are ensuring the redundancy in your application, spreading your application into 3 fault tolerance zones or 3 fault tolerance hardware, software, whatever you can say. But you may have the question next level. Suppose if the availability domain itself is gone, so then the fault tolerance or the redundancy will be, the control will be shifted to the next availability domain or next availability zone. And if it goes beyond that, you will have the regional level, which is what we look at. Typically, the regional level is the last level. And the failover is one part, in the sense, again, if one gets failed, it will move, the control will be automatically shifted to the other these ones. So as a user, you even don't know that something happened, in the sense, even because without your knowledge, without your these things, all these things will happen behind the scenes. But you need to do the initial setup to make this happen. Okay. And the other important things I want to talk about with respect to high availability is load balancing. So whenever your traffic is coming, the load balancer will be distributing the traffic to various servers or various instances available. So if at all, if the load becomes more, it can definitely balance that, in the sense, it can definitely is intelligent enough to understand that this particular instance is having bandwidth. Let me send the traffic to that instance. So that is the way it will be able to route the traffic to the concerned instance and get the things done, right? So this is in a nutshell about high availability. And the disaster recovery is more when something which is beyond your control happens. Say there is a hurricane, or there is a tufan, there is some accident, your data center is completely gone down, there is a transformer failure in the data center. Either of these things, we need to probably look at either alternative domains or alternative regions. So the way these things will be connected is, we can pair and connect, establish the connection between these regional centers, so such that they can be automatically failover to the one which is working, right? So the disaster recovery is the extreme case of this one. And how we can measure means, there are a couple of metrics. One is the recovery time object or recovery point object. So recovery time object and point object are nothing but, it is basically talking about the tolerance your application can hold, in the sense like how much tolerance, how much downtime your application or your organization can allow. So if you say, my organization is okay to take a hit for 8 hours, so RTO of your organization is 8 hours. But if there are some organizations which will work 24/7, 7 days a week, for them RTO is, say, they'll say that we cannot bear, so 0. So in those cases, how we can manage? So those are the kind of metrics. RPO is nothing but in terms of data. So how much data you are allowed to lose. So you can just, any company may say, okay, boss, I'm okay to lose 4 hours of data, or I'm okay to lose 1 day of data, because I'm okay to recreate that data. But if at all, if it is 2 days, it will be too much for me. I'll not be able to handle. So that is your metric for your recovery from a data standpoint. Okay. So one is to measure the infrastructure standpoint. The recovery point object is more to talk from a data recovery standpoint. Okay. So this is about the high availability and disaster recovery. So I think in terms of the concepts, what I want to talk about, these are the things. So guys, so cloud is going to be the important thing, because post-COVID, right? I think we are doing a lot of things on infrastructure, right? This Zoom meeting itself is one thing which is going on. So the cloud and these services associated with cloud are going to be more and more apparent, and the kind of skills probably which can be associated with cloud are DevOps. So when I say DevOps, I think there will be a lot of good opportunities for people who learn and get some Docker with Kubernetes and those kind of stuff. And similarly, for cloud and infrastructure, I think it is always good to learn about these various service providers, how they provide these IaaS, PaaS, and SaaS kind of stuff. How basically, for you to be claimed as a cloud architect, you need to be in a position to understand the problems, right? If an organization come to you and say, hey, I want to move from my on-prem to cloud, but in phases. So what are my first applications which I can migrate? What are my next set of applications? So you should be in a position to understand and give him the guidance. That is what is a typical cloud architect will do. And sometimes you may have additional responsibilities of complying with the government regulations, complying with the data residency of a particular country. And the people also in Europe, we are talking about GDPR. So all those regulations also you need to keep in mind, so that you can give the right kind of suggestions and help in terms of solutioning a particular organization from moving from on-prem to the cloud. So that cloud architect, cloud migration engineer, these are some of the titles you can think through. And automation. With everything happening in the cloud, I think as Kiran mentioned in that example, we just shifted for automating one of the infrastructure installation from 45 days to the way we got it to 10 days, 1 week. Now with Docker, we are doing it in 2 days. So automation is always going to be the hot topic. Automation need not be, because automation means people think about QA. It need not be just QA automation. It can be automation of infrastructure. There are so many scripting languages. You have Chef, you have Puppet, you have Ansible, you have Terraform. So all these things are really hot in the market now. So you can just learn about it. And cybersecurity. Cybersecurity is also, with everybody leveraging cloud, I think security is becoming an important thing. And I think if you can really master your skill and knowledge on cybersecurity, I think you can be definitely in a good position to take over the opportunities available and all that. But just to conclude, what I want to say here is like, see, how much ever you learn these things, I think, guys, just remember these 3 parts, the 3 C's, which I want to tell you before I conclude. Because these are the core engineering attributes which we all need to, including me, we all need to probably keep continuously reminding ourselves. One is our curiosity. We should always be curious to know and learn more and more. Don't limit yourself to learning a theory or doing some certification. That will not be sufficient. You need to probably look at the use cases to see if at all, if you can develop a solution, if you can solve some problem. Because your learning should not stop. Your learning should help you in terms of either solving a problem, and if you don't have anything to solve, at least involve in the research, because there are so many research papers available. If you read a lot of research papers, you'll understand what kind of business cases people are really working on, what kind of problems they are dealing with. So that curiosity is one important thing which you need to continue to possess. Second thing is your common sense, right? Common sense is more in terms of what makes sense in the current context. So you may have a lot of data available, but how you can use the data, how you can massage the data, and how you can derive some intelligence from data, and how you can probably understand the pattern, come out with some product or solution. That all will be the analytical aspect of your part, which is your second C. The third C is what? Though you have the curiosity, you learned something, you arrived at a solution, but you should be having the third C, which is your communication. So take that communication part and convey and build your communication soft skills, build your negotiation skills, build your convincing skills, and what do you call, advertise and socialize your solution and product. And these, today it is a social world. So how much ever you be active on this social media and socialize your learnings and solutions, that much you will be able to gain the success. So I'll be ending this session with this code. What is that? What is, which will, this thing is, the fortunes will always favor the prepared minds. So I assume we are all prepared. So I think we are all going to take these unprecedented times, and we will definitely make use of the best thing. Okay. Thank you for the time. And Vishnu, I'm done with this. Thank you all for your patience in listening to me. Over to you, Vishnu.
Thank you. Thanks a lot, Sharad sir. It's been a truly very informative and engaging session. I'm sure many people have got to know new things. And guys, I've shared a feedback poll. I can see it on your screens. So
Right.
please fill the feedback poll. In the meantime, sir, if you could just stop sharing your screen, I'll share my screen once.
Oh, sure. I'll do that. Yeah, I did stop.
Yeah. Yeah, guys, is my screen visible, everyone?
Yes, Vishnu.
Okay, thank you. So anyway, a quick note on the remote internship program that we are doing. So this is the most unique remote internship program out in the market, and as you can see, it's in collaboration with IBM, VMware, and IUCE. So we had a terrific run in the previous years as well. So what's interesting this year with the remote internship program is, as you can see, we are offering it on the 6 main emerging technology tracks: AI, ML, robotic software developer, blockchain, cybersecurity, and IoT application developer. So the things or the features that sets it apart from the rest of the programs is the platform that we are using, the Smart Interns platform, is inculcating both project-based learning as well as an industry-driven interaction. So you'll be getting a company like environment. You're having guided labs for practice, and we'll have 24/7 mentor support. And after, as you know, the perks, you'll be getting a training completion certificate, an internship letter, as well as a project completion letter for the duration of your internship. So there are 3 programs that we have: Career Basic, Career Plus, and Career Pro, as you can see in 3 different models. So the basic mainly deals with free internship plus learning videos and project work. But if you think that you require a bit of mentorship, you require a bit of guided mentoring support, then you can choose for Career Plus. But if you feel that you require the full and support, like on to Career Pro, and the basic difference in Career Pro and other programs is, in Career Pro, we'll have live interactive sessions with the trainers. We'll have live mentor classes and dedicated mentor support for every one of the participant. So that is about the what you say, the remote summer internship program that we are posting. So please check this out. I'll drop the link, and as well as I will also share the same thing in your mail IDs. So I'm putting it in the chat right now. So please go through the website in detail and get back to us if you have any other queries. I also request everyone to please finish the feedback poll.
So one thing, Vishnu, was like, I think there was some gap in between. No? So I think you'll be editing that when you are really posting the webinar, right?
I'll try to edit, but I think we'll be editing it as it is. So
okay. Yeah, because there was some, I think, 5-10 minutes of
yeah, it's fine. It's fine.
Yeah. Okay, fine. Yeah.
Okay, last 2 minutes, guys. Thank you for coming out on a weekend. Please be tuned to our social media channels. We'll be coming up with more webinars, and we are having remote internship programs. And for students who are tuned in, we are having IBM Hack Challenge. If you have not known before, so the people who are interested to participate for free of cost, we have IBM Hack Challenge, which is open for the whole nation. It's a countrywide challenge. So we are giving 6 problem statements that are plaguing the society right now, and asking you to develop a solution, basically a working solution, by end of June 30th. June 30th. So you're not alone in this process. So for now, we are supposed to pick a team, choose a state problem statement, just come up with an idea and submit the idea by the 7th June 2020. So we are starting our first online bootcamp on 25th May. That is this Monday, guys. So if you are able to register in this IBM Hack Challenge before Sunday, you can be a part of the boot camps that is happening on Monday. So, okay, the process is, as I told, choose a team, submit your idea. Then we have online technical boot camps like you have gone through right now, the cloud computing, but these boot camps will be more on IBM Watson services, AI visual recognition services, more on machine learning, how to upload the data into cloud, mobile app development and all. Then we also have digital mentoring sessions by technical experts, which will help you to architect your product in the best way possible. Then finally, we have the project submission by June 30th. So you have ample amount of support and guidance and mentorship that we are giving, so that you can be the top 30 winning teams. So what is at stake for you all is, for each person of the top winning teams will get 25,000 worth prize. Every participant will be getting a participant certificate for valid IBM submissions. And as you all know, you'll be earning IBM skill badges, you'll be getting access to technical boot camps, and also you'll be getting access to IBM Academic Initiative account, which is like the next, it's like a higher level of normal standard account. We'll have free courseware and softwares that is able to access and develop better projects. So this is all at your disposal. So please make the most of this opportunity, and you can learn as well as build a working prototype to make good for the society. So this is IBM Hack Challenge. So let me give you this link as well. 1 second. Yeah. So here is the link, guys. I'll also be sharing this IBM Hack Challenge link in the mails as well. So please stay tuned to your mails. You'll be getting by end of the day. Most probably you'll be getting the mails by end of the day. So I think that's it from our end. Thank you for making this webinar a success. It's been a pleasure having you all. And once again, thank you, Sharad sir. Thanks a lot.
Thank you. Bye, Vishnu. Thanks, Kiran.